second and final presentation is titled Advancing Composites That Meets the Needs of the Infrastructure Market and is given by John Busel. John is Vice President of the Composites Growth Initiative. He has been with the American Composites Manufacturers Association during more than 40 years of career in composites. John has led composites industry programs in market development for infrastructure and construction, and he also has been very active in codes and standards development. He promotes composites through education and awareness to engineers, architects, owners, and specifiers. He has worked in market development, composite design, tool design, and engineering manufacturing, and research and development of both thermoset and thermoplastic composite materials. He is a fellow of the American Concrete Institute and a member of the American Society of Civil Engineers, Society of Plastic Engineers, and ASTM. He was the chairman of ACI Committee 440, FRP reinforcement, a very, very important task that John led there. He's active in standards development for ACI, ACE, IEEE, and ASTM. I have worked with John, in fact, on ASTM, on ASE standard developments. He has been recognized by ACI for distinguished service. He's chair of the SPE Composite Division, and in 2019, he was a recipient and inducted into the ACMA Composites Industry Hall of Fame. John holds a Bachelor of Science degree from Bradley University. I welcome John.
Okay. Well, good morning, everybody, and thank you, Joe, for the nice warm-up act. He covered a lot of different pieces of information that I'm going to spot on a little bit, but I'm also going to pick on a couple of things that were brought up in the keynotes earlier this morning. So my presentation is advancing composites that meets the needs of the infrastructure market. So I'm going to provide a little bit about what has kind of happened, and I'm going to propose a number of things that we could be working on as a community. So here's a outline of the presentation. I'm going to talk a little bit about standards development because it's a key thing that has happened over the past 30 years in particular, being a part of it. I'm going to talk about some key installations that I think are going to be a very good springboard to the future. Overcoming the barriers, posing a couple of questions for this community to discuss, some target goals to work towards, and I'll conclude. So, you know, one of the things that I feel like I've been a part of since the very beginning was the development of the FRP rebar code. This is kind of like the Holy Grail. This particular document was 4 years in the making, but there was a previous 15, 16 years ahead of that with the design guideline for FRP rebar used in concrete. This has become a very critical document and certainly noteworthy. One of the things they note here is that it is currently being updated for the 2027 code. So expect some more new material, but also refinements on the existing material that's in the standard. To complement that, and we've heard a couple of examples of structural strengthening or wrapping of columns, to have a structural strengthening code is another big development within the concrete community. Again, this didn't happen overnight, but certainly solidifies the work that has been done in the composites industry globally. This is the document I was talking about, the design document 440.1, and it provided some very good background in design for concrete, and it's been used globally. It has been translated in many languages, so it is certainly a reference document that will continue to be serving a very good purpose. It is currently being updated to the 440.11 code, and so expect something more in the coming year. Boy, I spent my career on this one. And first of all, trying to do LRFD was a major milestone. To do it with pultruded composites was another. This particular document was 10 years in the making after the previous 10 years of doing the background work for it. I'll tell you that it is a prime document that has met the test not only of time, but to practitioners out there that had a very high bar as to what they needed to know about FRP. ACMA is currently developing a tutorial series on this LRFD. And so stay tuned. It's a 5-part tutorial that will cover the entire gambit of utilizing FRP in structural connections and seismic design, as well as all of the typical subjects that you would normally find in structural design. A new AASHTO guide is available, and this is really fun because ACMA back in 2006 drafted for the review of the AASHTO committee T6 at the time for a design guide for FRP pedestrian bridges. So that was 2008. Now we're in 2025 and we have a brand new edition, and it's been elevated to an LRFD on top of that. So it's good to have code and commentary. One of the unique things is that it's certainly written in an LRFD format. I think probably the most valuable part is that it has a robust commentary for engineers and designers on how to apply the uses of pultruded FRP, as well as sandwich construction that has been shown in Joe's previous presentation, and cantilever walkways. Of course, there's always something new. And the next one that's coming up with the Committee on Bridges and Structures is composite tub girders. This is, as it was talked about in Joe's presentation, it's authored by Dr. Bill Davis, and it's led by the AASHTO task group of the AASHTO Specialized Structures Committee, a committee that we need to be working very closely with. Hopefully the draft will be completed in January of 2026, and balloting of that document by the state bridge engineers by mid-year. So in the previous couple of years, we've had a number of things that have been put into place with FRP. And it was shown in one of the previous slides from Joe, and I take that back, from Kelly's presentation on the LRFD for bridge design. This is on GFRP reinforced concrete, and it was done in 2018. There's a current revision that is going on, and I think the big major change for this is harmonizing this with the FRP rebar code, along with other technologies. So this is a prime example. I know that the AASHTO Cobb's Concrete Committee has got this on their agenda for 2026. So be on the lookout for that. So it's been a privilege and an honor to represent the composites industry for the past 30+ years on an emerging market called infrastructure. And it's really been cool to be a part of every one of these things that are listed on the slide. Nothing like being in the very beginning of what a FRP deck would look like, putting GFRP rebar into concrete bridge decks, working on girders at the time being all pultruded, even wind fairings to help the aerodynamics of some structures. Concrete reinforcement between rebars and tendons and dowels. There's a whole slew of different applications, and concrete strengthening, which was a very good and important tool for a lot of the DOT engineers. And as it was brought out in one of the previous presentation slides, you know, the benefits of lightweight, high strength, corrosion resistant. Those are the calling cards for FRP, but design flexibility. And that's the one thing that composites can certainly provide. So I'm not going to spend too much time with these, but I just want to give you that little tour. So concrete strengthening and repair. There are thousands of installations that have utilized both carbon fiber and glass fiber to retrofit, to extend the service life of existing structures, to seismically upgrade those structures. Prefabricated bridges and bridge decks has made a transformation in how one would then utilize composite products in the field to minimize installation, to increase faster times. The one thing that always gets me, and for those that are in the Washington, D.C. area, the Wolf Trap Bridge, which spans the Dulles Highway, nothing like shutting down that highway for 15 minutes while they're lifting a FRP deck into place. Couldn't do that with normal construction. So this is certainly unique opportunities we need to take advantage of. You know, and with the Key Bridge in Baltimore being struck by a ship, I think what we're going to see more is bridge pier protection. This is not new to FRP. There are certainly many installations that are shown here, both in Florida, in Virginia, in Delaware, and even in New York City. And they recognize what FRP can bring to a very corrosive and aggressive environment. We talked a lot about the GFRP tub girder or the composite tub girder, and it's going to lend itself to accelerated bridge construction. This is great examples of applying materials and a technology to expand the horizon. So there's two different bridges that I want to note, and they were significant because of what they delivered. One was the Harkers Island Bridge replacement in North Carolina. And as the slide says here, first bridge reinforced with FRP rebar and pre-stressing strands for girders, decks, bent caps, and piles. Okay. This was unique. This was cutting edge. This is the state of the practice. So we need to go forward and learn from these applications and in this particular structure. And it was such that PCI handed this the 2025 Transportation Award for its structure. Joe just covered this on the Halls River Bridge. This is a great playground of a bridge utilizing and having it being steel free on a lot of different technologies, both girders, decks, abutments, foundations, and it's a prime example of what we should learn from. And I know Joe in the previous presentation had talked about the decarbonization element and the value that came from not only the life cycle cost analysis for this bridge, but what it would do for sustainability. So as we look to the future and we're overcoming the barriers, what does that look like? So sample needs of the customer. Faster installation and field direction. I think that was brought up in a number of different conversations. Reducing labor, and not necessarily on the manufacturing of these products, but in the field. Construction jobs are becoming much more on an increase, and we have to think about the amount of personnel that's really out there to construct these, let's call it higher technology installations and bridges. Always to look at increased safety and inspection of those structures and how we best go about doing that. Certification of products, and this is going to be a very key thing that I see happening for the composites industry in the future. Yes, long service life, that's in the DNA of composites, but we need to demonstrate that. We need to showcase what that means. Sustainability, I know Joe just talked about sustainability, but does that and is that going to be a factor in bridges of the future, especially given the current administration? But what is that going to look like? And is there a need for that? And I know Kelly brought this up, reduced costs. I used to do a slide back in 1994 and, what do engineers, what are the top 3 things that engineers look for? And I said, cost, cost, cost. Made no difference that it was the space age thing. It made no difference that it was technically the most achievable thing. It all came back down to cost. And at the time, they were looking at material costs, so the direct costs associated with getting it in the field. But what was being neglected, and certainly not given enough weight, is what is the cost of that structure over its lifespan? And the use phase of composites, whether it's sustainability or even for life cycle costs, that's where we benefit. So, I use the analogy that, hey, I'd like to drive a Lamborghini. I can only afford a Hyundai. There's a little bit of that. And I think we have to put things in perspective. So what does that future look like? Some suggested goals for construction. Doing things that are easier to specify, standard elements or components or modules so that it will be faster to assemble and transport. Automation of the manufacturing process. And it has a lot of implications to that, whether it is, excuse me, reducing the labor, but enhancing the repeatability and increasing the quality and as well as increasing the production. Education and buy-in by the end user. That's going to be a chief thing. How do we educate the end user so that we can help them feel that the risk that they're taking on using innovative materials is worth it? And I can't underscore this because it really comes back down to risk. And there are a number of people that I know from the top of my head that have taken the risk and applied some very good technologies that still work today. And the one thing that I think about, and Dr. Roberto Lopez was a part of this, the McKinleyville Bridge, a 157-foot bridge in McKinleyville, West Virginia, was the first bridge utilizing GFRP rebar in the concrete deck. Well, there's been no maintenance to that bridge since 1997, and it still is a work of art today. So let's look at that, some of those older installations and have that feel and reduce that risk of what that could be for the future. I throw out here, create an app. Everybody looks at our smartphones today. We're always looking at apps. And boy, it would be nice to dial up a composite product on an app and kind of see what its durability is or what its strengths are. So how do we create that tool for the user? So one thing I was asked to address is Build America, Buy America. And we have a very unique message for this. So for all federally funded infrastructure projects, we need to show that we meet the requirements of Build America, Buy America. Composites may be considered either manufactured products or construction materials. And the agencies have the purview to provide what that direction looks like. So for manufactured products, final manufacturing must be in the US, and the US inputs must exceed 55% of the value. So that's an important component. From the construction material side, it's a combination of the constituent materials that must occur in the United States, but this means that imported resin or fibers may also be used. So these are very important distinctions on the Build America, Buy America, and we can talk offline about that. So in conclusion, what does advancing mean? Developed standards over the years, having large key installations that are noteworthy, that really push the envelope, shows to me that there's a greater acceptance of the technology. And, probably very few people in their careers can say you were at the very beginning and towards the end of your career, like me, you are looking at a lot of the successes from all of the seeds that were planted over the years. No doubt, the other part of DNA of composites is constant innovation. So we have to balance innovation with applying technology. Standards and educational tools are going to be incredibly important to educating engineers. We also need to provide those tools that grab the attention of young engineers. And I don't exactly know what that vision looks like, but we got to figure this out. And one of the things that will always translate is that as businesses expand, operations will become more efficient. And I think just because of the technology that is out there. So a couple of things here. We have a new event coming up in the fall called Composites Evolution. It's going to be a very unique event for the small to medium manufacturers in the composites industry. A lot of things that we'll learn during that exchange that will include demos, that will include tax incentives for business owners. So something that if you're in the neighborhood of Knoxville in late October, please stop on by. And with that, I will conclude my presentation, and thank you very much.